Okay, here we're going to look at the continuous uniform distribution. This is where it's sometimes called the rectangular distribution because of the way it looks on the graph. If we look at a frequency function where we have f of x here, it looks like this. Completely flat between a and b. And the function can be written f of x, let's tidy that up, f of x equals 1 over b minus a when x is between a is less than x is less than b and 0 elsewhere. So what does that mean? Well, it means that the height f of x is constant between a and b, and it's 0 everywhere else. So there is no probability of it being anything else, and it's an even chance at any point in between there, or any range. And the way it works when we do it is with continuous data, you never have a single point. What we have is a range. So for example, if we had a continuous graph that looked like this, five and 9, well then our height here, our f of x, would be 1/4. And if we wanted to find the probability that x was greater than 7, well, we'd look at this here, we'd say here's 7, here's 9. What's the area of the shape? Well, we've got 2 across and we've got 1/4 up. 2 times 1/4 equals 1/2. The probability x is greater than 7 equals 1/2. Close that bracket. And that's really all there is to it. An easy way to think about it, if we're wanting to do it, as well as it's going back to the idea of relative frequency that we saw in, maybe when we first saw probability in year 9 and year 10. So we have our predicted, or our targeted outcome, or in other words, our successful range over our total range. So here we have 2 out of 4, 2 out of 4, or 1/2. And it actually works out to be really easy once you get your head around the continuous normal, but you have to do a couple of them so that you start to recognize these sort of problems.